Okay, today's lesson is Unit 4, Lesson 2. What you're going to be able to do today is compare functions, whether they give you an equation, a set of points, or even a chart or a graph. You're going to be able to compare the two functions mainly by looking at their slope. Slope is also called rate of change, and remember it's a rate that describes how one of the quantities changes in relation to another quantity. So it could be the price per item that we're comparing, it could be the speed, it could be how many miles were traveled per gallon of gas that we're comparing. So the units, remember, are going to change, but slope is still slope, and depending on how steep a graph is, it usually is pretty easy to tell looking at a graph which one costs more or which one has a greater speed, but we don't always get a picture of a graph. As you can see with this first example, sometimes we get an actual equation to look at. We talked about equations having this format called slope-intercept form, y equals mx plus b. And we know that m is your slope, and that slope tells us how things are changing in the problem. It's the rate of change. The y-intercept, remember, is the initial value, and that changes depending on the situation, whether there's like an initial fee or a deposit that has to be made and so forth. Mainly we look at rate of change when we're comparing functions, so that's what we're going to focus on. The first function that I gave you, function A, it definitely is already in y equals format. So if we pick out our slope is right here. Our slope is 2. What that means is we're rising 2, running 1 on a graph. If we were to kind of show a picture of this, we can always sketch it. But before we can do our slope movement, remember you need to make sure that you have your y-intercept. So let's pretend your y-intercept is right about here. Remember, that's our beginning point. Begin with B and then move with M. We have to move so that we're rising 2, running 1, rising 2, running 1. Again, this is just a sketch, so I'm just going to very roughly remind you what this line would look like. Okay, it's pretty steep. If it represented the price per item, remember it would be like $2 per item. Or per person, depending on what you're going to do. This equation over here, though, function B, it needs some work. If you remember, we did a minions puzzle on this topic, and the idea is this is still a linear equation. It's going to look like y equals mx plus b, but we have to do some work to it. So remember, you're going to want it to say y equals, so that means we need to move the 3x. And we do that by subtracting, because this 3x is positive. We want to get rid of it. We're going to bring down. We still have a negative 4 attached to our y. And on this side, remember, you cannot combine plain numbers with x's. So what we typically do is we want the x term first, and then we want the y-intercept or the constant term down here. To finish the problem, remember, we wanted to say plain old y equals. Right now we have a negative 4 attached by multiplying, so we said we always divide by that coefficient, even if it creates some fractions. Out here, we're getting our y equals that we want. This fraction is going to stay 3/4, but remember, a negative divided by a negative is a positive, so I'm just going to write down 3/4 x, and then this luckily divides out nicely, so we have a y-intercept that is a whole number. If we wanted to show a sketch of this graph, we could. We'd have to indicate that its beginning point is down here at negative 3. And then this time, guys, our slope, which is located right here, we have to show a rise of 3 and a run of 4. So again, I'm very roughly going to estimate where this line would go if we were doing the movement piece. And again, very roughly sketching. Again, I do this because to me it's easier to look at the graph and say, hey, this one's way steeper than this one. But guys, we can do the same thing just by paying attention to the actual value of the slope. 3/4 or 0.75 is obviously much lower than the number 2, which we got in our first function. So if we were comparing A to B, A would have the greater rate of change because it has the bigger slope. Now, I want to go over using our formula for slope. And if you recall, when you have 2 points, each point contains an x and a y value. So the first thing that I want you to remember about using your slope formula is that you have to label your points, okay? If you don't label your points, you're probably going to plug into this formula wrong, and you're not going to get the right slope or rate of change. So, using my formula, I need to take y2 minus y1. Again, this was my first point, so I called it x1, y1. Every point has x and y values. This is my second point, so I called it x2, y2. And so if I need to find the difference between my y's, here's my y2. I'm subtracting my y1, which, yes, happens to be negative. That's going to happen sometimes. x2 minus x1, here's my x2, and my x1. So the math on the bottom of the slope formula is easy. On top, remember, keep change, change. We end up with a slope of 10. This is a very, very steep line. If I wanted to sketch it, all I would know is that I'd have to rise 10 and run 1 to get to my next point. So this one, if you kind of imagine, is very, very steep. So we'll do one more. For function d, we have 2 points again. So again, label it x1, y1 for your first point, x2, y2 for your second point. We need our y2 minus our y1 and our x2 minus our x1. This time we get a 9 on top, but we get a -3. Remember, you're going to reduce. And this time I get a pretty steep line, but it is a -3. So if we were to imagine what this looks like, whatever your beginning point is, you'd have to go down 3/1, down 3/1. It's pretty steep. But if we were again comparing these two functions, this function would have the greater rate of change. 10 is going to be a much steeper slope, rising 10 and then 1, 10 and then 1. So again, if we were looking for the greater rate of change, function C. Alright, so looking at the other side of your note sheet, we have a table of values. When you have a table of values, sometimes it's easier. We can still use our formula. We would label these as your 2 points that you're working on. These are all x's. These are all y's. So you could label this x1, y1. You could label this x2, y2, and you could still use your formula. But guys, for this, I thought we would pay more attention to the pattern, and we kind of use our formula that I mentioned there a while back. Change in y over change in x. Okay, you can actually see the change in y pretty easily in this particular table. What you would do is take all the y's and start looking for a pattern. From 0 to 6, from 6 to 12, and from 12 to 18, do you notice that you're increasing by 6? Okay, we would call that our change in y. Our y values change by adding 6. We would have to do the same thing in the other column for your time, which is your x values. And in this case, again, the pattern's pretty easy. You're going to see that it increases by 2. So we call that the change in y over change in x. As always, you're going to reduce. So this function has a slope of 3, and if you wanted to label it, it would be feet per minute is how you would set up your units. This table is sideways, so be really careful. All your x values are at the top. So if you wanted to use your formula, this would be x1, y1, and this would be x2, y2. And you could go through and use your formula. But again, I kind of wanted to have you guys focus on the pattern for these tables, because I think some kids are really good at finding the pattern, and it's easier than using the formula. So, change in y's. Be very careful. In this table, my y values go across the bottom. So if I'm looking for a pattern from 4 to 12, 12 to 20, and 20 to 28, I think we agree on an increase of 8 with our pattern. And if we look at our x's, it's 2 again. Guys, this time when we reduce, we see that function f, this one over here, has the greater rate of change. It goes up by 4 feet every minute compared to 3 feet every minute in function e. So again, if we were looking for the greater rate of change, we have it with function f. Now lastly, and my favorite, is looking at a graph. Remember that you're going to draw your slope triangles, which means you have to connect 2 points that actually cross the grid. You're going to connect them with this little right triangle, and you're going to carefully look at your units. This one represents a rise of 1 box and a run of 4. So this is not a very steep line on our function at all. This one's much steeper, and it came with some units, so let's pay attention to the units. According to this, if we have 0 money raised, we didn't run any miles. According to this, we would have to go up, let's see, that's 10, probably 15 is the amount of dollars raised for somebody who ran 2 miles. So that's actually my slope. Okay, remember you're going to count boxes or pay attention to your scale. 5, 10, that's $15 over 2 miles. And if we reduce it, we would say it's $7.50 is how much money you're raising per mile. So maybe it's some kind of fundraiser where you're running and people are going to donate money for your cause. So $70.50 a mile. Guys, if we want to use the same units over here, and this is the amount of money I'm raising, 1/4 reduces down to 25, right? 25 cents, 0.25. If we wanted to use the same units, that these are the money raised and this is the distance in miles, we could do that, but as you can see, this would be a not very good fundraiser. You would only earn 25 cents per mile if we use the same units compared to the $7.50 per mile over here. So again, if we step back and you have to compare these two functions, this one would definitely have the greater rate of change because you're earning way more money per mile compared to this one, plus it's steeper. And again, we can tell that just by looking at the graph. So guys, comparing functions really narrows it down to paying attention to slope. You want to be able to find slope with your triangles. You want to be able to find slope using a table and looking for the pattern. And you also want to be able to find your slope if you get an equation or if you get a set of points and you have to calculate your slope. So I hope this serves as a very good review. You're going to cut your note sheet. You're going to tape it in your book now. And then I've got some practice problems for you to work on.